Test.
Yep, looks like we're getting decent sound out of it, so.
Okay.
Like I said, I'll just man the live stream all day. If there's any questions in the chat, I'll kind of raise my hand.
Okay,
and get
sounds
to
good.
me when you can.
Okay.
And when we have the gadget running and stuff, I'm tethered within 6 feet here to the camera, but I can move it around and zoom.
We could have put this closer over here.
I think it'll be okay when I move. I can zoom in as long as I have clear line of sight there.
Yeah.
So, yeah.
Okay.
And I got 6 feet to move to.
Yeah.
Or 12 feet. I guess if I give you that, I can just do this and take this down and get 12 feet.
So I'm just gonna introduce all of this, so we can come up when we. Did you guys able to get the clicker to work?
It was last week.
Hmm.
I'm not sure why. I can text Kelly maybe.
That's all right. I'll just run the thing.
Sorry about that.
No, that's no big deal.
Okay, I think we'll go ahead and get started. We're looking at 10:01 or so. Thank you all again for coming for this last week of professional development. We really appreciate you, everyone who's been able to come for one session or 3 sessions. Some of you coming from all over the state, hours away, so we really appreciate it, and we appreciate everyone on the live stream voting us as well and watching the recordings. We hope that the previous 2 professional development sessions and this one have all been a valuable experience. Today we're going to be focusing a lot on hands-on learning with the gadgets. The gadgets are pretty cool. They got the camera, they got a line following sensor, but we'll get into all that here in a little bit. But with that, I will go ahead and turn it over to Troy Harding, who's the department head for integrated studies here at K-State Salina. He, along with some other folks from the integrated studies at K-State Salina, are going to be running our summer camp. So that, Troy.
Okay, thank you, Kevin. Hello, everyone. Welcome to K-State Salina for your third round. If I could have the integrated studies folks come on up here, we'll kind of introduce you guys. So I don't know how familiar all of you are with our campus. You've been on our campus. In fact, if anybody wants to do a tour later after we get done here, we'll be glad to take you over and show you our labs and that kind of thing. So a lot of what we're talking about today relates back to things that we're doing in our programs here at the college level.
Not sure that mic's.
Oh, is it not working? Can you guys hear me?
Oh, no. Yeah, yeah, yeah. You might just have to hold it.
Okay. Yeah. Well, it's going to introduce you, so.
Oh.
So I'm just going to pass the mic here and let each of these guys introduce themselves. I'm Troy Harding. My teaching background is in the computer systems technology area, and you can see we have several different areas represented. These are all areas within the integrated studies department, and I'll talk a little more about that in a second here.
Hi, I'm Tim Bauer, and as I said, I teach in robotics and automation, but that's an integrated department, and so I also teach in computer systems technology, same as Troy. So that's one, we have computer, mechanical, and electronics is all sort of part of robotics and automation.
I am Chad Bailey, and I am an instructor in the Electronic and Computer Engineering Technology program, but the UAP worked the longest program title, right? But yeah, really excited to have you guys on campus today, and we get to have some fun.
Hey everyone, I'm Mike Pritchard. I'm the machine learning economics systems professor here. Also, same with Tim, with I do computer systems as well. So, programming 1, programming 2, JavaScript, Python. So we do quite a bit of an overlap in our department. So anyway, I'm happy to be here. Happy to see everyone too. So is everyone properly caffeinated? No, I didn't hear enough laughing.
That reminds me,
Yeah.
my caffeine's in the back there. I need to go get it.
I am not. So I need a couple more.
So those are, so you see that there are several different areas that were represented up here, and that's pretty much that top row here, but that's not all. We have the mechanical engineering technology within the department. We actually have a UAS design and integration. So last week you were working with the flight operations folks. I think Michael was here, is that correct? So last week you were working with flight and operations. We also have a design and integration side of the UAS, and that's within the integrated studies department. Digital media, web development, and even we have an applied business and technology degree within the department. So quite a variety of things. In addition to the general education classes, the communications, science, math, all of that's humanities are all inside that department as well. So when we say integrated studies, it really is a lot of disciplines, and it does give us an advantage of being able to bring some of those skills together. Everybody wants technical people that can communicate and have a good, strong leadership skills and project management and those types of things. So that's really the things that we're trying to bring together in our department. Yeah, if you want to go ahead and hit that. I don't have a lot of slides here, but I do want to again emphasize that if anybody's interested in touring our labs, we're more than happy to do that. We are going to be creating some videos for the camps so that your students will be able to get a feel for what we do in our labs, and we'll kind of give an overview of what that looks like and some of the careers and those kinds of things. So when we have the summer camp, at least the students will get exposure to some of these things and get firsthand, secondhand from the videos. But we do have labs, manufacturing lab, electronics labs. We have a new AR, VR lab, robotics and automation lab. And we're continuing to build these out. We're investing a lot of money and even changing some classrooms around into lab spaces this next year. Just very hands-on oriented. That's really one of our trademarks. A lot of active activities, hands-on projects. Students are doing hands-on projects from their first semester here, building portfolios, and all the way into their senior projects. And so it's a process that they all go through, but they're building up their skills. So sometimes when we have students that are working on their senior projects and at the level that they're doing it, so that we have newer students coming in, they're like, oh my gosh, I can't do that. How do you? But when you're a senior, you can. So you can just kind of build up. And so that's really kind of the message we want to make sure that the middle school's kids are seeing and thinking about this as a career. You can do this. We have done summer camps on our campus for quite a while, and one of our seniors who's graduating here just sent me a picture last week of when he was in one of our camps as a middle school student. And you know, here he is, he's graduating and getting ready to go out into the big wide world. But it's really cool to see that progression, and so your students can do it too. And we want to get that message out there. Yeah. Okay, so again, I don't want to spend a lot of time talking because we do want to get into the hands-on activities here, but just to kind of give you a idea of what the schedule is going to look like, we're going to do a little bit of an overview on robotics, just kind of a high-level overview of what the different types of robotics are, and then after that we're going to jump right into using your gadget robot and do some things with that, and then we'll close the morning off with talking about AI, what is AI, and do an activity centered around that. All right, and then in the afternoon we'll load on our block coding, and you guys have done that in the last 2 weeks, so you're very familiar with what different types of environments there. This one is called Picto blocks, but it is based off of Scratch, so if you've done Scratch before, it'll look very familiar. And we'll do some activities using that code block process. So, all right. So, any questions or suggestions based off of previous labs or previous weeks here? Because otherwise, we'll just go ahead and start in on the robotics conversation, and I'll turn it over to Tim. All right. All yours, Tim.
Okay.
And I'm going to give you this as well.
Oh, yeah.
So they can hear you.
This
This is for here, and this is for
Oh,
them.
you got to have both.
Yeah.
Okay. All right. Does this have to go on my belt? There we go. Is that working okay for you? Okay. All right. So again, I'm Tim Bauer, and I'm, as I said a minute ago, I teach in both robotics and also in computer area. So what I do with robotics is primarily related to the computer programming part of it. I teach some sort of introductory programming courses that all the engineering students take, as well as I teach a course specifically on robotics programming and another one on machine vision, which is of course important to robotics. So that's my involvement. Okay, so part of the idea of this talk, and also I think the same could be said for what Dr. Pritchett's going to talk about later, is really to kind of help you when we actually do the summer camp with the kids, to give them a chance to kind of open up and talk. And you know, kids love to tell stories about what they know because their dad did this or that, or they have an uncle that's doing that, or whatever. And so part of this is kind of intended to be fodder to kind of help them open up and get engaged, right? And so I'm just going to kind of talk a little bit about robotics to give you some material. And of course, I think these slides will be available for them when we do the summer camp, so if you want to change them or whatever, that's great. So what is robots? And so what I listed there on the bottom is kind of the industry standard definition. You know, like anything, you know, it had to be argued about a lot because everyone had different opinions. But what's listed there is more or less the consensus that you will find virtually anywhere on the web or and in any technical journals talking about what is a robot. So we say it's a goal-oriented machine that can sense, plan, and act. And so obviously, with sensors, you have to have extra. It's not just a computer, it's not just a machine, but you also have to have sensors that are going to be able to tell you what's going on around you, and then based on that, make decisions as far as how you can act or what the robot should do. Okay. Is that? I don't know sure if that. Okay, so I'll let you drive. Okay, so why do we need robots, right? And so this is in particularly maybe a slide that when we meet with the kids, they'll get them to talk. And so we need robots to do things that people can't do, don't want to do, or won't do, and shouldn't do because of danger and things like that. And so I have the next coming slides. I have some examples, which but the thing is, the examples can just go on and on forever, right? I just have a subset, if you will, of some specific ideas of how robots help us in these sort of three categories. But this would be a good time to get the kids to try to kind of, so I mean, maybe I don't want to spend too much time on it now because I know we've got a busy schedule today, but what are some things that you can think of that robots can do that people just physically can't do? Yeah. Underwater, yeah, that is a good application. We have a lot of research in underwater robotics and things like that. Others? Yeah, because you can get long-term injuries from repetitive motions. What about don't want to do things that people? It's hard to get people. It's like you can't pay me enough to do that. Yeah. And that's also. Actually, I have one of the slides or the pictures I have later is a sewer inspecting robot. That's a good application. Other things that people don't want to do. What about things that people shouldn't do? I heard something.
Bond disposal?
Yeah, right. That's a good application. Yeah.
Well, that's what it is. I read about because they had a robot going in Chernobyl and
Dangerous environments because of radioactivity or, yeah. In fact, I don't have a picture of a nuclear facility, but I do have a picture of where we've got high voltages going on, and they're just with the magnetic fields or electric fields that are going on. It's just they don't allow people to go into certain areas, but yet they need to be inspected, right? So they do the 4 Ds: difficult, dirty, dull, and dangerous. That's what robots. Next slide. Okay. So just some other ideas of things that robots do that people can't do. Lifting heavy objects. Here we have a big industrial robot lifting, I don't know what that thing weighs, but a lot, right? And so that's obviously an important part. And in our robotics and automation program, we do some stuff with both industrial robots and mobile robots, but really the money's in the industrial robots. That's what's going on to help with manufacturing, and so that's really our emphasis. And I think with kids, though, I think the mobile robots tend to be an easier platform to get into, and so hopefully that drives their interest enough that they want to think about the more commercial applications as well for when they get out in post-graduation. Working into small places, right? We talked about the sewer inspecting or pipe inspecting, and that also, you've probably heard a lot about surgeries with robots, and so that's a case where, with a robotic. Go back. Sorry. It's okay. Right. So with the robotic surgery, people can recover much smaller incisions and able to get into some really tight areas. And this is kind of an area that we think of as more teleoperated. In other words, the surgeons are controlling the robots do have sensors and can kind of help the surgeons, but ultimately it's the surgeons that make the decisions. And one of the things that it does is just kind of, the surgeons have, like joysticks or gears, things that they move, but it's scaled such that, if the surgeon moves something an inch, well, it's just going to move that knife or whatever it is, just, millimeters. So you can get much more precision than what a person could do sitting there holding a scalpel. Right, so good application of robotics, particularly the teleoperated, right? And sometimes robots can, they can just operate with a higher level of accuracy, and they can operate sometimes very fast. So that's helpful. Okay, so some things that robots or people don't want to do and shouldn't do, all right? So we talked about the sort of the boredom factor and this is let's see, does this, try this, yeah, that works so this picture here, that's a packaging system, right? And so the robots are mounted on the ceiling, and they can work very, very fast. And you can see in this case that there are multiple of them, and they work coordinated. So if the first one misses an item when it comes through the conveyor belt, the next one will get it, and is used to package, right? So that's kind of a really boring job, and it's also one that speed is really needed. And so people don't want to have to work that fast. It's a little, right? The next one, I find this, this is the Boston Dynamics Spot, which is physically modeled after a dog. And that's probably the most famous or well-known of the mobile robots that are that have legs as opposed to wheels. And there are actually some other competitors to Spot. Some other companies have similar robots. And this is actually probably the fastest growing area of robotics that there is. There are literally, millions of these guys being sold. And you can see here we're in it's like a power distribution center, and so there's some really high voltages going on inside there, and places where they need to be able to visually inspect certain parts of that on a regular basis. But you don't want, so you're going to walk on a walkway with thousands of volts on either side of you, and you trip, you're dead. That kind of, so very, very dangerous environment. And so they use these dogs to go through, and with cameras, they think they can visually inspect. They're also used on oil rigs out in the ocean. They're used on these cargo ship containers that cross the ocean, because they have to, those things are huge. And you have to, and there are people that do this, but they're finding out that the robots are a good supplement to this. But you have to go around and make inspections, make sure all those containers are where they should be and are fastened down properly. That the waves and stuff don't jar or loose a fastener, right? Because that would be disastrous if those things start moving on you. Here's your sewer inspector, right? So, and they have those different sizes. That's a little bit bigger one. They have them really small, ones that you'll just, hold in the palm of your hand for smaller pipes, and then bigger pipes. But that's a really good application, because not only do you not want to go there, but you physically can't. You can't crawl through a little pipe. But these guys can't. So next slide. Okay, so we talked about industrial robots. Industrial robots are very consistent. They're accurate. They're reliable. They're actually usually fairly easy to program. And a lot of times, though, with industrial robots, it's more about integrating the robot with the bigger picture of what's going on in the factory with the control system we call PLC, Programmable Logic Controllers. So if your middle school kids have never heard of the term PLC, this is a good time to enter, because there are definitely more jobs in industry for PLC programmers than there are for robot programmers. Right? A lot of our department, we call it robotics and automation. And everybody hears that term robotics, and that's just what they call it. But I always think, automation, that's where the money is. That's what you really need to know to be able to be successful in industry. And so shown here are some pictures, and there's obviously other types. So this is what we call a vertically actuated serial link. We say it's serial link because you've got joints, and then you got a physical link, another joint, a physical link, and they're sort of in serial, right? So we call these serial link arm robots. And then this is you would call this a SCARA robot, or also referred to as a horizontally actuated robot, right? So you notice that all the joints are all sort of it moves in a plane, right? And so this is typically used a lot of times for packaging applications or other applications where you can maybe envision, a conveyor belt is bringing products down in front of that robot, and it's moving. It's maybe picking up items, moving them over for packaging, very fast. And they can also be used to like screw down. You can put a screw bit on the end of it and over and whoop, really fast. And this is a parallel robot used for, this is like what the packaging one we looked at a little bit ago. There's also gantry industrial robots, which are sort of over, like there's a crane-like structure kind of thing overhead, and then the robots hang down from the bottom and are used for primarily material handling, positioning heavy parts into positions that are needed for manufacturing. Okay, next. Okay, mobile robots, which is primarily what we're going to be working on. Okay, this is, in my opinion, the fun part of robotics. I mean, they're all fun, but this is, and partly I say it's fun is because it's not quite as precise. We say it's less deterministic. The industrial robots have very accurate gearing and things like that. We know where that end effector is on an industrial robot. We don't always know exactly where a mobile robot is, or we may know close to where it is, but not exact, right? And do we know necessarily what's around it? Even less so, right? So we very heavily depended on sensors, all kinds of sensors. And of course, this gets into even things like self-driving cars and that kind of stuff. Huge growth area, mostly solved, but not completely. There's still a lot of challenges out there related to self-driving vehicles, mobile robots, and that kind of thing. And one of the things always and this applies to any kind of robotics application, you have to frame the project or the problem in a way that a robot can solve it. Robots are very good at doing what they do. They're not very good at, like people have asked me before, can I have a robot in my house that's going to cook dinner for me? Well, maybe if you have a very prescript kitchen, and everything is like, if it's going to, but if just like, oh, where do you keep your pans? Well, wherever I have room for them. If it's that if you're like most people, your kitchen probably won't work for a robot, right? That's where humans are much, much better at adapting to the environment than robots. And so we have to sort of frame the problem in a way that robots can be successful. This one's this is a warehouse application. So these robots will go around, these things here, they can pick them up and move them to like where other people are going to be shipping things out. And you may have other people scattered out in the warehouse that these guys would come to them and they would pick out products and put them on containers, and then let the robot do the hard or the strenuous task of carrying those objects from where they are in the warehouse to where people are that are gonna package them and ship them out to be mailed to people. This is a mobile forklift, and a lot of times on those, it's very much kind of like our wall following, or not. I'm sorry, not wall following, line following. Sorry, another robotics application. A lot of times they'll have magnetic strips or things like that in the floor or other way, and so that these mobile robots that are moving around and taking things from one place to another inside a manufacturing facility, they know to follow the magnetic strips and things like that. So we don't really turn these powerful machines loose to just run over people, right? As well as they do have obviously sensors. So if someone walks in front of them, they're going to sense you and stop. There's a little bit. So here we have kind of a combination. You have a mounted serial link robot on top of a mobile platform. So this is a pretty advanced robot there. Lot going on with that to make it work. Okay, next. Okay, so robots in education. Okay, I think most of these robots pictured here are ones that we have had some experience with, and some of these you probably recognize. This is an Edison robot. We used those in another camp a couple years ago, and they're very. How much did we pay for those? Those were like cheap, weren't they?
Yeah, they were I think it was $30 if you buy them.
Yeah, so a little bit cheaper entry level platform. So maybe if you want to.
Legos on top of them so the kids can kind of customize their look.
Yeah, a little bit, more limited on what they do than the gadget robots. And I'm sorry I don't have a picture of the gadget. I didn't have a picture, but you can throw one in there later if you want to. This is called a Now robot. These are pretty sophisticated and kind of expensive, but they're cool. You can lay it flat on its back and it'll stand itself up and do all. Kids love to look at them. As far as mobile robots, this is one that I've used in my robotics programming class. It's similar to the gadget, but a little different. It has a Raspberry Pi, which is good and bad. A little bit more capability, but then the problem is that now, how are you going to connect to it? And one of the nice things about these gadget robots and other ones that are powered with like either this ESP32 processor that's on the gadget or on like an Arduino processor, is that you just run a cable from your computer to the robot, and that's how you download the program to the robot that way. Whereas with these, like a Raspberry Pi based robot, now you've got to be Wi-Fi, and so now you have to worry about the networking and the IP address and all that kind of stuff, and then connect to it. And then you get connected to it, and it's Linux, which may be problems, So right, but if you can get over all the hurdles, then you got some pretty cool platform that you can do some interesting programs on. And then also I showed a couple of pictures. I don't know if you guys in your schools have done any competitions. They can be a lot of fun. This is a middle school competition. This is First Lego Leagues. So they're using the Lego Mindstorm platform, which I've used that too. And I really like Lego Mindstorms. They because not only kids can build stuff with them, and they can build their own robot fairly easily, and then they also can be programmed to use sensors and to drive around or do So not just, you can also you can build a serial link arm robot you can do a lot of different things with Lego Mindstorms. At the high school level, this is a little bit higher end. This is First Robotics League, or FRC, First Robotic Competition. I don't know if any of you have ever seen those. Those are a lot of fun, a lot of excitement, but it's pretty high bar. They're expensive, and although there are grants. So I don't know if any of your school districts, are any of your school districts doing anything with either First or Best Robotics?
My nephew does it in Manhattan.
With First?
I don't know. He lives in Manhattan and he does that. I've watched it.
Yeah.
That's all I know.
Yeah. Yeah.
On the bottom one, I don't know, are any students with Technology Student Association, DSA, or anything like that? Because they just did a state competition, and they used vector controllers. They look a lot like the ones on the bottom.
Yeah.
Like the record set.
They're a little smaller. These I don't know if the picture really shows. The Vex ones are sort of bread box size.
They can modify them for the competition.
The competition I saw, they were, about that by that kind of. These guys are like that, but they're big.
These are, you can kind of get them up to a certain size, but
Yeah.
I just wanted to throw that there in case TSA would work.
Yeah, TSA is a good. Yeah, I've done some stuff in the past with First, and so that's why I put First pictures up. So, okay, I think that's, yeah. So, any questions or any points of discussion about robotics? One of the things, and I know Mike's going to hit on this later when he talks about artificial intelligence, a lot of robotics, especially like the industrial robots, there's not a lot of artificial intelligence. It's more deterministic, right? But when you get into like the mobile robots where we're saying it's not completely solved problem, that's where really the artificial intelligence comes in, like the self-driving cars and that kinds of things. And I know Mike will get into some of that discussion later. So, okay. Okay, Chad. Oh, here, let me give you this too. You want the pointer?
No, it's okay. Or yeah, I guess that's good.
Yeah, this red button is the laser.
Okay. All right. All right. So we're going to talk a little bit about some of the hardware and software aspects of robotics, and a little more of kind of the bringing it down to the middle school level a little bit, and maybe even the hobbyist kind of level. We could put a big industrial robot in one of your classrooms, right? And just like have this big, massive thing moving around. And I worked at a manufacturing facility here in Salina, and they had these huge cages around these industrial robots because they're very powerful. They would, I worked at Philips, and they made fluorescent light bulbs, and they had these, what we call a skid, these skids of glass which just piled up. Well, sometimes those robots would go a little crazy. They'd get a really weird signal, and they would just crush all the way through that pile of glass. And to see the power of those robots. I went over to Dubai for a competition we had at Philips, and in one of the malls there, they had one of those robots with like 2 seats on it, and they did this roller coaster thing. And so you could sit in that and then do a roller coaster. I'm like, there's no way I would ever do that, because I've seen what those robots can do. So yeah, you get a good respect of those types of robots. Those are great skills that we're trying to, hopefully for our graduates, that we can teach them up to that level to go into the industrial environment. But where do you start? And so hopefully that's what we're trying to do today, is give you guys some ideas on where do you start. So next slide. Okay, so there's a wide range of platforms, I guess, to start with. Has anybody used Arduino? Yep, some of you, okay. So Arduino is just very simple. It's kind of a hardware and a software thing. So there's just a few examples here. There's the Uno, there's Nanos, there's all kinds of different ones there. But Arduino is just a very simple platform where you can get started and connect sensors to it, push buttons, it can run motors, things like that.
With Arduino, though, it's more of a text-based coding. So you're typing in text, and if you don't have a semicolon in the right position, or you miss a comma or things like that, it can be a nightmare. I was working with some students in the lab, and they flipped some letters in their code, and so it was looking for a different variable, and they just sat there for like 10, 20 minutes trying to figure out what's going on. So sometimes text-based coding is difficult for middle school students. Maybe around high school age is kind of, in my mind, that's a good place to kind of start with them. But Arduino is definitely a good platform. So I've built different projects using Arduino, and I really like getting students to use Arduino. They're really inexpensive, but they are pretty powerful. Next. And then there's the Raspberry Pi, like Tim was talking about. The Raspberry Pi really came on the scene. The creators of it, they wanted to have very inexpensive computers that they could put into the classroom. That was kind of their goal. And they were around the $35 mark. So now with supply chain issues, they're around probably 100, if you could even, 150, yeah, so if you can even get them. But what's really cool about the Raspberry Pi is that you see I'll use the laser pointer here. You see these pins up here. You can actually connect sensors or like lights, little LEDs, or different circuits directly to it. If you have a desktop or a laptop, typically you have to have other accessories, little plug-in devices to make that work. But this is very easy to integrate and connect sensors and circuits to it. There's different versions of this you can get. Most of them are, I think, like a quad-core processor. They've got 2 to 8 gigs of memory built in, HDMI outputs, USB, all kinds of crazy stuff on these. So really, really cool devices. So if supply chain gets straightened out, eventually maybe you guys will use it. Has anybody used the Raspberry Pi in your classrooms? Okay, a little bit. All right. So yeah, they're a lot of fun. Learning Linux is a great thing. When I was in school here, the computer science students were learning Linux. I'm like, why would you ever do that? Why would you do command line text stuff? But it's very powerful, so it is fun. Okay, next. And then there's what we're using today is called the ESP32 board. This is actually a 32-bit processor, so it has a little more capabilities than like the Arduino boards do. So if you're all nerdy about that kind of thing, it's a pretty capable board. You can program it with the Arduino IDE, which is just text, and we'll get into that later in the afternoon, showing you that a little bit. But this board has a camera built in, which is kind of slick for doing some different things with. And really, there's a lot of applications for this. So we're going to get you started on something, and then you can kind of explore later on with it. But I feel like sometimes the hardest part with robotics or electronics is, where do I start? Sometimes those things are so daunting. So hopefully this kit will give you a starting point and give you some examples to do that. And we'll work with the students on some of those activities as well this summer. So this is the board we're using for that. Okay. So I've worked with middle school students in the past and have done some different things, some different summer camps here. And we've bought different kits. We've had good luck with some kits, not so good luck with others. So I've partnered with Juniper Robotics, and we're working on trying to develop some kits that are very useful for middle school to high school students. And have Alex Mole here from Juniper Robotics to talk just briefly about what you guys do.
Hi, I'm Alex Mole. I'm the operations manager at Juniper Robotics. First of all, thank you all for being here today. I can't tell you how excited we are at Juniper to see so many people in this state and around the country now that are just so, hi, you following me around? Oh, I'm sorry. I saw some laughs out there. I was like, oh no. What'd I do now? Hold on. There we go. Okay, is that good? Am I coming through? Okay. Well, I'll just hold this and try not to push any buttons. Anyway, as I was saying, I'll try to be brief here. Thank you all for being here. It's really good to see how interested people are becoming in project-based learning. Excuse me. It's one of those things that I think it's an invaluable asset to inspiring the next generation of engineers and entrepreneurs and, you know, intuitive minds and that sort of thing. So we make educational kits for the classroom. Gadget is our most recent one, and our goal with Gadget was to not only create something that was accessible for a younger audience, but was also engaging enough to keep a more experienced student involved. So we wanted to use the block-based coding and, you know, all the way up to Python and C++. And Troy's input has been wonderful, and I thank you for hosting this, Troy. And Chad, of course, thank you so much. And yeah, I'll give it back to you here.
Okay. All right, so I guess we'll just start there. That'll work. As I mentioned before, the Arduino IDE is mostly just kind of text coding. So you're putting in stuff, and Arduino is really great because it made things a little easier. But it's still text-based. Go to the next slide. And then there's other programs like Scratch, EduBlocks, PictoBlocks. So PictoBlocks is one that works with the ESP32 board that's on Gadget. So we'll do a little bit of activity with this later this afternoon. But PictoBlocks is kind of a neat, fun program to be able to do some programming. You can do the little character on the side, make him do animations, but then you can actually dump different code onto your robot and drive it around. So, okay, so go back. All right, so working with middle school students, I've worked with middle school students in the past. They're a lot of fun. They got a lot of energy, so you kind of got to keep up with them. So they're kind of like herding cats, you know, I guess, right? You guys all know that. You just try to, maintain the chaos, try to control it. So a lot of times what we'll do is we'll start with a little activity, and then we'll let them explore, and then just try to regroup and do another little bit. And I noticed some of you were already kind of controlling your Gadget robot already, so that's good. So what we're going to do is you guys can pull the Gadget robot out of your box if you haven't already, and we're going to just drive it around a little bit. So, yeah. And Alex will tell you that you're lucky to get it out of the box. Some of those boxes were kind of tight fitting, so good luck with that. Yeah. So, so you notice a lot of these kits were 3D printed, and so my thing with some of these robot kits is they got to be functional and they got to look cool, right? Which is always helpful. And they got to be purple, yes. So we can customize it, yes. So that was a big thing. All right. So with this board, what's kind of cool about the way this board works is that you can just connect to it with a web interface. So when you power it on, we push the little button in the back. Hopefully it doesn't take off the table for you. But when you turn it on, okay, there you go. What it'll do is it'll broadcast a Wi-Fi access point. So then you can, on the bottom of Gadget, there's a little, there's the SSID, the Wi-Fi address. So if you pull up your phone or your tablet or your laptop, whatever, and you connect to that Wi-Fi spot, so it'll be Gadget and then whatever number you are on the bottom there. If you connect to that, you can then pull up a web IP address. So if you pull up Safari or Google Chrome, whatever you have, you then type in an address, and I don't think I put that on there. So it is 192.168.4.1. It's on the, okay, cool. All right. So then everybody in the room will have a different access point, so that might be a little interesting thinking about that now. There's probably going to be a long list you have to scroll through to find your, but once you find that, you can place it on the floor if you want, drive it around. There's the,
Or take over somebody else's robot.
yeah, that's right. I didn't put passwords on there. I probably should have done that, but So if you're using a phone, you can just kind of use your thumb to drive that little purple knob around. And so you can watch it on the screen. So I don't know if you guys know about the FPV. We have some UAS students that fly quadcopters with just the goggles on. So this is kind of a little bit like that. You can see how good you are driving from the camera.
There's going to be a racing competition later.
Yeah.
Yeah, you're welcome to get up and go find a space on the floor and try to drive it.
Yeah. Go.
I have a track.
Yeah, I made a little track here, but
So when we're working with the middle school kids, when you kind of get to this part of the activities, it's like one of the early activities of driving the robot around. You might give them a challenge, like maybe you guys could try yourself. If you want to try to drive your robot to follow the line by just using the camera, not or maybe you have a partner. In your case, you'll probably have kids working with a partner. They could have maybe one person watching the robot, the other one's just using the phone or the interface and trying to use the camera to drive. Kind of judge to see how well they do. You can make a little competition. Every time they go outside the line or something, they lose a point. You can set up chairs and try to drive through an obstacle course. Just some things like that. So I think you guys are experts at that age level and coming up with lessons, but that's maybe some things we can talk about today. If you guys have some ideas on how you might create an activity around using this capability right here, I think this would be a good conversation to have, and then we can incorporate that into the jam. So, okay. Does everybody get theirs to work okay? Anybody have any problems? So if it stops responding, just refresh your browser, and that usually fixes it. Yeah, it's just for a little while. Yeah.
Hey Sherry, and anyone else watching, really, one of the more common problems that we've run into so far is that it will disconnect sometimes. So the first fix on that would be to refresh your browser if it disconnects. And from there, if that still doesn't work, then just turn the gadget on and off again and reconnect through Wi-Fi, then refresh your browser, and it'll work. That's something that will get fixed in an updates, I'm sure, but if that's a problem that's still present in the summer camps, just kind of a turn it off and back on procedure.
Okay, did everybody, everybody able to connect? Any issues still with connecting to the robot? Hopefully everybody gets to drive around a little bit. There was a little maze I put up here, just a little line. We're going to follow the line later. I went really low tech with the line. We were talking about printing out some big sheets and stuff, and I thought, well, maybe just low tech. We'll see how it holds up and go from there. But so I might point out a few of the things here. So you notice on top is the ESP, this 32 board on top here. Let's see. So this is the processor and the Wi-Fi connection, everything built into this top board. There's the batteries underneath. So if you take out these screws in the purple hatch there, you take out those screws and then the batteries. There's two replaceable batteries down underneath there. So the camera's right on top. So you saw the camera. And then the front two, we call them eyes. Some of the way they're printed, some of them look like they have eyebrows. It's kind of fun, but that wasn't really intentional. They just kind of came out that way. I know. It's a feature, yeah. And then there's these two sensors here. It's one sensor. It's an ultrasonic sensor. So what it does is it actually sends out a sound wave, and it'll bounce off an object and come back. And so it'll then time how much time it takes for that sound wave to go out and come back, and it calculates the distance. So we can also do that with this, kind of like how bats navigate, the sonar with the sound wave going out and coming back. So And then underneath, there's two sensors underneath. There's two line following sensors. There's a infrared, like an LED that shines down, and then there's a detector right next to it, so it'll sense the line. So we'll play around with that a little bit after lunch. So a few sensors to kind of get you started and working with some of this. And then we'll work with some of the block coding as well. But all right, any questions? Yeah.
What's the range between the controller and the actual robot?
That's a good question. It probably depends on some of the whatever's in the room as well. But I don't know. I haven't actually tested it. I don't know. But it'll probably go. I was in my basement and I was driving around and it was a pretty clear opening, so I could probably drive it from here to the wall fine. So if you have a small classroom, maybe that it would be in there, but something to test out and try it. Let's see, what else was I going to ask? We did run into some issues with the iPads, so some of the iPads would not connect to the web page for some reason, so I don't know if that's a security thing that's established on those iPads.
Yeah, it could be a whitelist thing, and before the summer camp starts, we'll send out a whitelist to your tech department just to say these are all the websites we need for all 3 weeks. So you can see, we're waiting on that until the curriculum is fully developed for the summer camp, but as soon as that's ready, I'll push that out to all of you and your administrators. Yes.
Can you get that pushed out before the end of the school year? Because it'll be difficult to get our tech before the summer.
Yep.
My school will be.
Yeah, we can make that work, yeah.
Okay. All right, any questions? Okay. Yeah.
I'm getting conversations on ideas of activities we might do with that.
Okay.
The future of it.
Yeah. So for the summer camp, we'll plan some activities. So some simple things like make the robot go forward, make it come back. But we want this to be really interactive also. So if you have some ideas of things that maybe you see that you could do with the robot, we can maybe share some of those. And if you have any ideas right now, now's a good time to. Do you see yourself using this in the classroom for any activities? Yeah.
I'm gonna drive it around in my classroom to get my interest in some of the labs.
Yeah. That's perfect. Yeah. Okay. That's good. Yeah. That's cool. Yeah. It kind of depends probably on your floor color also, what kind of tape, different colors, just having that contrast. So I wanted to tape off the whole room. It'd be kind of fun to have them going around, but yeah. So yeah, doing something exciting. That's cool. Anybody else? All right. Well, Michael, I think you're up next for a little bit of overview of AI. So.
Do the special dual mic.
The dual mic handshake.
Sure. Am I connected? Can you hear me on online? Okay. So we got to do this internally, that externally. Hey everyone, how's everyone doing? So I've got the artificial intelligence session. So I think the question that's probably on everyone's mind is, and I know that I get this a lot, is are we going to be building Terminators eventually? So artificial intelligence, I imagine the big question is like, you hear artificial intelligence, you hear machine learning, you hear data science, you hear all these different. So my job here is to kind of connect the dots on a few other things. We also have a little activity for
deep learning, which will be kind of cool, using teachable machine. But I do have a little quick back and forth here. So I'm a professor of machine learning autonomous systems. We get into the area like Tim had talked about. He's, the robotics and automation. When we say automation, it's PLC based. It's very what we call it's old school. What we call old school AI from the 80s, actually earlier. It's all if else then. It's very specific logic when you want things to be done a very precise and specific way. And the way I like to explain what machine learning and autonomous systems does is we take it from non-deterministic to what we call stochastic machines. And if you think about the way that a human learns to, we're just biological machines. But if you think of the way that we learn to grow up, and like something simple like learning to walk. As a baby, the baby doesn't like have this training data to work with. It's like, okay, you see a baby walking, it's like, step this way, that didn't work, right? Step this way, that didn't work, I fall over. It's a very stochastically driven process because what the human mind is doing is it's doing a trial and error process to lay down some procedural foundations of this is how I walk. So it's starting to lay down that. So if you think about the way the human mind develops over the first 20 years, especially when we're talking about procedural movements, it's very much getting into our wheelhouse. So anyway, let's talk about this, and next slide. Okay, so thinking back, I want to see how many people, how far back do we think the historical roots of like artificial intelligence goes back? Any, throw a number out, how far back in history?
Like of it actually being, or of people thinking?
Precursors, like the foundational building blocks. What's that? How far? Ancient Greece. Okay, so that's a good. That's actually pretty good. Okay, so that's. Okay. Well, if you're thinking it just right, if you're thinking human, just brains in general, right? I like it. Okay, that's good. So, I like the Greece is really good. So if you go back really that far, right? I like to break it up into like a cultural kind of notional cultural concepts. So prior to that, does anyone remember Hesiod's Theogony, right? Hesiod's Theogony? None? Pandora's jar? We call it Pandora's box, but it's Pandora's jar historically, right? Pandora is created artificially, right? It's not, so the concept of humans created this in the literary text really early, right? The idea of creating something, this artificial being, right? So go fast forward, right? King Arthur, kind of, well, actually, even before that, like think of Jason and the Argonauts. What was, there's this big Talos, or Talus, depending on who you talk to, big giant mechanical automaton, circles the island of Crete, right? It's mechanical. They were thinking of like these mechanical beings, right? That's why I like the Greece. That's very good. Go forward, King Arthur. King Arthur wrote about the Arthurian legends, right? Whoever Percival, right? Wrote about these copper men that would run around, terrorize the knights. So all kinds of fun stuff. So fast forward. So when it gets really kind of cool is, when do you think like the really first bedrock of like technologically speaking, outside of literary context? Throw a date out there. Think math. I won't go forward until I get a date. 324. No, I like it. I like how far we're going back. I like it. So 1560s. There's a guy by the name of Cardano, Italian math. Well, he's a polymath. He laid the foundation. He wrote a book. Called Games of Chance. And so that laid the foundation for statistics. And what's funny about that is the guy was broke because he had a gambling problem. So he was like, how do I make some money off, I need to figure out a way. So he wrote this theory of games, put it in a book, and that actually, again, it's kind of funny, but he laid the foundation for statistics, which lays the foundation for machine learning. because then Thomas Bayes comes along in 1750s, says, I'm going to build this thing called conditional probability. We call it Bayes' theorem. And so we move forward from there, right? Then we get into the 1950s. Next slide, please. Okay, so now we get into the artificial intelligence. So getting past all that fun history, 1950s, we get into artificial intelligence because we start to get into actual computational machines. Computational machines that were mechanical were actually been around since the early 1800s. But when we get into the 1950s, that's when we get into stuff that can actually do some things. But it really fell off the map. AI just was like, you know, you saw a lot of sci-fi shows from the 50s. It was like, oh, look, we're going to have robots everywhere. The computational power just wasn't there back then. Then in the 1980s, machine learning kind of picks up because, again, there's this kind of resurgence of personal machines, and, you know, we've got these desktops and PCs, and it starts to get into it's a little bit more accessible. It kind of falls off. Then deep learning comes onto the scene in 2010. 2010 hits, and then we get into this deep learning. And so this is where I think people are like, what is the difference between deep learning, AI, all these type of different things? Anyone want to take a stab at it? Next slide. Okay, so artificial intelligence, it is the umbrella term, right? It's anything that we're trying to make something else do for us. One of the things I like to say is when you're thinking about the use cases of artificial intelligence, we have a tendency to say, well, we're trying to build something that does something better than what a human can do in certain aspects. And when we get into when you're talking about deterministic machines, man, there's no way humans can do that, right? There's no way you're going to take a 1,000 pound piece of sheet metal, lift it up, weld it. Humans not going to be able to do that, right? And efficiently, it's not going to happen. But we did build the pyramid. So, but with that said, on the other side of it is there are things that we do really, really well, and it's the pattern recognition, things like that that it's very difficult to get machines to do that. But we're getting there, like Tim had mentioned earlier. Think of Tesla, right? And so where I'm trying to get you think of like self-driving cars, things like that. We kind of hold artificial intelligence machinery to a standard above ours in a way, but then we get really upset about it. So as an example, how many accidents per million miles do you think humans crash? How many crashes for a human? How many? I was surprised by this statistic. I actually had to go to the NTSB to figure this. But how many? Did we get a number? Yeah, I thought a lot, like a lot. Per million miles. How many? Any numbers? Huh? It's a lot. That's what I was thinking. I was like 15, 20. It's actually 4 on average, surprisingly. And I got to thinking about it. I'm like, well, how many times did I crash a car? So, but probably don't use myself as but yeah, it's 4, which surprised me, right? And I'm like, oh yeah, there's safer drivers out there than Mike Pritchard, so that makes sense. So how about Tesla now? Per million mile of automated or autonomous systems, and I want to use that word, autonomous systems specifically. How many do you think? 10? 3. So the number's 3. 3 crashes per million miles on autopilot. And I think what's interesting is if you look at the news press and things like that, they're like, every time there's a Tesla car that crashes, it's like everybody loses their mind. Oh, see what happened? See what the machine did, right? But it's actually performing a lot better than humans are. And that's it's pretty interesting. So one of the things to kind of keep in mind as you're kind of thinking through this use cases and what that looks like. So back to this piece of it. Machine learning is a subset of artificial intelligence, deep learning. So this is what we're going to do a little bit today. So deep learning is a class of algorithms. So it's part of machine learning, but it's not like more better. It's not like I'm doing more better machine learning. I'm doing more better learning, right? It's not like that. Or it's deeper, right? That's not what that means. All it is, it sounds fancy, is it's artificial neural networks. It's a class of algorithms that's used specifically within deep learning. So outside of deep learning, in machine learning, we talk about clustering, classification, we talk about prediction. And those all can be achieved, but they use a broad set of statistical algorithms. Deep learning uses what's called neural networks. So that's it. And neural networks approximate the neuronal connectivity of the way the human brain is put together at a neuronal level. So they call it Hebbian cell complexes, things like that. That's what that's trying to approximate. So anyway, there you go, deep learning. Now you want to show people, you want to show off at a party, you just tell them it's neural networks. Okay, very cool. So let's talk about deep learning, but let's do it, right? I guess next slide. Okay, teachable machine. So this is a way to, there is a way to integrate. So everyone go ahead and pull this up on your machines. This is a laptop exercise. So go to that teachablemachine.withgoogle.com. This is an online, it's actually an online machine imaging software put out by Google. It uses a neural network, so speaking of the deep learning. And this is there's going to be 2 exercises, so go ahead and hit, let's see who's got it up. Okay, so go ahead and say get started. And then you'll go ahead and say you can do a pose project, an audio project. Go ahead and, I'm going to go ahead and talk through the pose project, so go ahead and just kind of open that up. So there's going to be 2 classes. Go ahead and do this. To do this, you'll need access to the camera on your laptop. So if you don't have that, you just have to watch somebody else do it. Then, so yeah, go ahead and hit get started. Yeah, perfect. And then we'll do and then what you'll do is you'll create a class. So the way these works is you get a classification. There's a class 1, which is going to be, you just go ahead and you'll hit the button, and yeah, there you go. And then you'll say hold and record. I got to get out of here. So this is for your face, and then you'll have to move around. So just go ahead and hold the button, hold record, and move your face around. Yeah, there you go, exactly. As much as you want, and then you can release. And then you go down to the bottom, and then you got to do a class 2. Now this is a little harder. It might take 2 people to do this. You have to stand up and do a pose while you, perfect. So you'll have to stand up and do a pose. So I can hold that one for you. And you have to stand up and do it so that you can get a pose, exactly. And then what you'll do, all right, here we go. And then, yep, so you might have to get a partner for this one and move around, and yep, there you go. And then you'll do a model training. Yeah, there you go, exactly. Do we have a webcam up here? Perfect. So then what you'll do is once you get your pose samples, and then you'll gather what we call training data for your face, and that's a class. So that if you think about the way we do classification, humans love to group things, right? These are apples, these are oranges, these are bananas. We're just really good at that. So then, is Troy's going to do it? So what you'll do is, there you go. So what we're going to do here is, we're creating training data, and we're using a neural network. This is all deep learning. We're using an artificial neural network to do this. So this is a class of face, right? And so what you do is you hold the button down, right? And then it creates different versions and different angles of that. And that's a classification for face. Then under that, you get a classification for pose. So because it's a different structure, right? There's more going on. You got arms, you got legs, right? So then after that's done, you do a train model. And then from there, you can export the model. Now, if you back up like even 3 or 4 years ago, this kind of stuff didn't exist. You had to do this all in code. So it was a tough process. So this is really cool. So what happens is once you export that, you can actually take that model, it turns it into a binary file that you can use in those little guys. Now, that's another exercise, but just wanted to give you an opportunity. Yeah, so you can, these ESP32s have the capability not to do the model training. So just a high level, when we're talking about machine learning exercises, especially on the predictive side, think about how human brain works, right? We don't just go and say, hey, we're going to learn to play football. Right? We don't just go say, hey, we're going to learn to play catch. You have to have some training data. You have to build that procedural memory up before you go. You just like, oh, right. So that's the same thing. No different. Biological machine, silicone machine. So we have to train it with some prior historical data, and that's what we're doing here. We're building up pose samples, historical training data, so that it can do classification in the future. Now, these machines can't do the model build, what we call the model build and everything that goes into that, but the binary file that it saves, that's the little mini brain these can run. So then you can save the model here, and you can do machine vision exercises on this. So where I want to make the distinction that a lot of what you'll do initially should be easy expert systems kind of. That's what that's the best way to learn initial parts of AI, old school AI. And then you can, these are nice because you can, because of the ESP32 architecture, you can actually move into more advanced things. So yeah, oh, there was a question. Yeah.
No, sorry.
Oh.
Making a video, sorry.
Oh, no, nice. See, we're doing some gesture recognition. Yeah. So, okay. So, oh, it's still training? How long has it been running? A minute? Oh, that's not bad. That's not bad. So just to kind of, so what ends up happening with, if you take this to like high school, take it up to like college level, take it up into graduate programs, like what so when you get into a lot of the higher level stuff, you need bigger machines to do, if you're going to do training data on billions of samples of data. Has anyone heard of GPT-3 in the news? Sound familiar? GPT-4, GPT-3. So let's talk about that real quick while this is going on. So there you go. So GPT-3, general purpose transformer is a general process transformer 3 is the current version that's been put out by OpenAI, and it's a big group. It's about 40, 50 people, and it uses a special wafer technology that is about 20% of what the human brain's capability is in terms of neuronal connectivity. We call parameters and parameter connections. It uses billions and billions of pages of human text, and it actually fools humans. Like, so has anyone heard of the Turing test? So Turing test. So the original idea behind the Turing test was, can I build a machine that fools a human into thinking that the machine is a human? Imitation Game, anybody? Homework, go watch the Imitation Game. So it's about Turing, it's about Bletchley Park. They actually took over for the Polish. They built actually the cryptographic bomb. But Alan Turing set up a lot of the really kind of the really, a lot of people would say, the really modern artificial intelligence researcher that ushered in a lot of what we do today. But where I'm going is that when you look at GPT-3 in terms of that Turing test, I think the stats were about 70% of people were fooled within the first 3 or 4 minutes that they were talking to a person. If you go on into longer, deeper conversations, you can start to pick up on, I'm talking to, what am I talking to? So it's very interesting. But GPT-4, which is coming out in about 4 or 5 years, that is a much bigger system, and it actually has so many, the wafer technology they use is very specific to this project. It matches the neuronal connectivity of every neuron in the brain up to that scale and size. It's huge. It's pretty cool. It's really wild. So the idea is at that next level, and it uses special, it's actually under lock and key. So they won't, GPT-3 is not even open source. You can go, they won't let people play with it. You got to have, you know, but GPT-4, I can't believe that part, but it's pretty cool. So anyway, some good stuff to research. We just wanted to throw some stuff out there for you to take a look at. But yeah, definitely Imitation Game, Westworld, Free Guy. Those are all great pop culture references for, I mean, if you want to get some fun stuff to kind of think about in terms of artificial intelligence, like the possibilities. Those are all great pop culture references to look into. I think with that, that is, was there anything else on that I needed to cover? Yeah, so get this to work with. Yeah. Yeah. So what you can do is keep playing with it, and we can see if you can do more with it. Has anyone gotten anything interesting happening on theirs? Except beeps, that's a good one.
How do you get used to, if mine just keeps, yeah, it doesn't ever reach the end.
Oh, that is odd.
That's what hers is doing too.
That's odd. These are kind of, it's just sitting here. So this is definitely one that is more advanced to, it just, yeah. Oh, you know what? Yeah. You have to have a pose structure for the second one. It did? Oh, it looks like
Well, maybe I talked to somebody there.
It might be too similar.
Yeah.
Oh, so I have to change?
Yeah, yeah, yeah. Is anyone having theirs like just sitting there like?
Oh, I did mine to where I can tell if I'm right hand or left hand.
Oh, nice.
Although I've got to be a certain distance, I think, flash usually. So I changed my prior email when I done that.
Yeah. So that's actually a good point. So this over here, this model is training the difference, understanding the difference between a left hand and a right hand. So it can, and it's showing the probability. So that's right. So that's actually doing what you would expect it to. Yeah. Yeah. Very cool. And then Troy's isn't. No percentages on yours.
So
We've got one working. We've got two working over here. Yep.
I tried it and then I gave up.
Oh, okay. It's definitely one to. It's a good one to show students when you kind of toy around with it. You kind of play with it. You can kind of yeah. Let's see. Anyone else? Oh yeah. No, here's another good one. That's even more precise. Nice. And so what's really nice about this is as you get more fluent with this and you start to get more fluent with the robot, you can do a lot of different tasks. So, which is I think what follow the line exercises, object collision avoidance. Yeah.
Do you know if camera resolution has anything to do with
Yes,
finer details?
it can. But for big stuff, so you'll have to exaggerate sometimes. But if you're doing like industrial grade stuff, like you're, so for example, like some of the research that we're looking into right now is if you're going to do survey of airframes, and you want to like detect cracks in the airframe, like you have to have a high resolution, of course, like almost like a 4K at a minimum, 4K camera. Yeah. So but yeah, if you're doing like airworthiness certification, things like that, a lot of times you have to have a human that's like kind of looking it over and kind of, but that's a time-intensive process. And so if you can build a machine that can scan your aircraft, right, that's a huge opportunity, yeah. But requires a lot of resolution.
Yeah, that would be one expensive sensor package.
Yes.
Just for the purposes of the classroom, though, with like Gadget, for example, it would be compatible with the software, but I'm assuming it wouldn't be able to pull off, very detailed gestures or.
No, with this one this one can do pretty good.
Yeah.
like,
stop, misses go.
yeah,
So there has to be enough difference between the two images, like
right.
like if you're comparing like apples versus bananas, there's gotta be enough like different shapes.
Right.
But if you're looking at like a football, if you're looking at like a football versus, I was trying to think maybe like a soccer ball versus a basketball or something, it might still be round, so there might not be enough contrast. So I think there's enough. If you're sitting there, it's looking at your face, and it's training the model of your face, but then the other image has to be different enough, so it needs to be more of like a stick pose or something like
Yeah.
Different.
Yeah.
I don't know if it will work on somebody else's face. Will it say like
That
Class
for
1,
the
Class 2?
yeah, it probably
Might not.
wouldn't be able to do that with this kind of resolution, but you can do like you wouldn't be able to say, okay, this is Chad versus Mike, unless there was like a very, like Chad's saying, there's a big divergence. So yeah, but it can do like you could probably get the difference between like an apple and a banana, right? Those kind, because there's enough of a variation there, and like a fruit or something. Yeah.
But like Chad was saying in his initial point, like it can recognize the open hand versus the closed
Yeah,
hand.
that's
But
right.
it doesn't necessarily animate that in like wireframe necessarily, or?
It could.
I think it
It
does.
could. It depends.
The gentleman back there were like, I don't think it can detect my hand, and there was no wireframe on his.
I think it's.
That's kind of what.
Oh,
That's kind of what.
I see
spurred
what
the
you're saying.
question of
I
what-
see.
What resolution would be required in order to get a fine detail, even just?
I think that's probably a limitation of the software and not the limitation of the camera. Yeah.
it might
yeah.
be the background too. If there's not enough.
If there's not enough contrast behind that, yeah, yeah.
But yeah, I've seen that. We've done some things with webcams in the class where it's open close, it'll
Yeah,
it'll
yeah.
change fingers.
Because I know you mentioned incorporating this, your name was probably you mentioned incorporating this in the gathering as a part of the machine learning aspect of it.
There's an aspect that I do that.
Yeah.
And that's what a lot of these colleges are looking for in their programs. Is
Yeah.
AI is kind of
Yeah.
the thing. And
Yeah. Yeah.
so it'd be great if we can incorporate that. I think.
Well,
Seems like it's definitely possible.
It's doable, and a lot of that is the model too. So this is just using teachable machine to generate a model, and if you wanted to do something that was a little more advanced, you could do a model gen that was not using teachable machine to create a binary that you load up on that. It would work just fine.
Do you know how?
You could use OpenCV or something like that. Yeah. Yeah.
Is this cloud-based?
Mm-hmm.
So
Yeah.
is all the data gathered from this saved and stored in the cloud somewhere, or
It's
is
this
real-time
one.
and just kind of deleted?
Oh, that part I don't know how the teacher.
As soon as I saw Google, I was like, how are they using the data?
Oh, sure.
I'm very curious.
I'm sure.
Like, wow, now we got gait
They
recognition.
they probably twin it, and then this is your model, and then
Yeah,
we've got
yeah.
this base data
Like,
now.
well,
Yeah,
give
yeah.
me your name, it'd be great.
That's right.
It'd be
That's
great
right.
if you could give us your name.
Go to the airport.
Yeah.
That's right. That's right. Now you're done. Now you're done.
Well, it's like the Facebook 10-year challenge. Algorithm that. Oh,
Yes.
this is what I looked like 10 years ago.
So we're sorry if you did the exercise with your face, and now the TSA has your your image on file. That's we haven't landed on that part yet in terms of because there's just a lot of it usually is we usually do the line following for the summer activity. That's probably do we have another? Usually it's line.
And I'm not able to get it on my iPad, which doesn't surprise me too much.
The iPad wasn't. Oh, the teachable machine wasn't. Oh, interesting. Yeah. We'll have to dig into. Yeah. Well, and we did find out that another thing too. Yeah, why some of the yeah, that'll be something we'll have to check into. It's actually pretty good. It works pretty good for yeah. His was running perfect. It was like right hand, 99, and then left hand, and then it would switch in 99, and yeah. It's pretty cool. It's actually a huge time saver. I was like, oh man, if you're gonna do something on the quick, and you need a model to like follow the human exercise, and then you just like, okay, here's a class for what a human looks like. Then you just build the model here, dump it, instead of having to do it manually, like take pictures, you know, because that sucks. here's my image training data, and then have it scan it and bring it in, and that's, yeah.
It'd be interesting to have like a green screen or something behind you to see that, like block out, or even a white screen, just not to like block out the back.
That's a good point, yeah. That's a good point. We had one of the students doing a vision exercise with a follow. It was just a mountain. It was servo. You know, it did like 1, 2 degrees of freedom. So it would follow. It was Morgan Perez. He had a dog. He like did a dog cutout. So he would have the robot, and the robot would like follow the dog picture. It was kind of cool. Okay, are we? Oh yeah, this is good. Right up, he's saying almost 45 minutes. I think. What do we have after that? Is that the end of the?
Yep.
Oh yeah. If we had time, he was saying install picto blocks. Do we want to have them do it?
It's a good,
I've got a question for you.
Yeah.
On Teachable
Mhm.
Machine, is that information processed locally, or is it?
It's processed in the cloud, and then the model then gets dumped locally. But that's what we were just joking. We're like, I wonder if Google saves the face data. You know, splits it, right? You know.
Right. I mean, they don't do anything for nothing.
Right. Like, hey, we're building up even. Yeah, that's what I was just thinking. Yeah. But yeah, it's processed
so the
external.
wouldn't be different from machine to machine that we use, because like our students are going to have Chromebooks.
Mm-hmm.
Their processing power is pretty limited.
Yeah. Right.
But it would be, since it's processed on
External,
the server,
yeah.
it won't.
It's actually the algorithms. If you back up 10 years, these kind of tasks used to take. You wouldn't do them. It was so hard to build training data, especially with image processing. But the algorithms and the laptops have gotten so good. Like I remember when we were doing some stuff at a prior company I was working at, and we were just trying to do some simple things, and it was like taking an hour to build a model. You know, you're sitting here processing on your laptop, and like, oh my gosh, it's taking forever. But it's gotten to the point where on a lot of laptops now, I mean, we'll process models, and we can do it on our laptop, and it's, you know, you're talking about a couple minutes. It doesn't take much time. But if you're doing really advanced stuff like 4K image, you know, you want high resolution, then you're getting into, and you're doing like billions of records that are really wide, then you start to get into, I need a GPU, I need to start getting into, Tesla. Yeah, Tesla has a special, they've got it shrunk down. They used to use the AGX. They used to use these, we have 8 of them here, but they've got AGX, it's all heatsink too. It's a little guy with like, it's just about 2 pounds of heatsink, and it's almost all aluminum. But it's a shrunk down self-driving kit. And if you're looking to do, if you guys seen like universe simulation, like what physicists will do, like they n-body simulations, when you're doing stuff where it's like you want to map out all the celestial objects, all the asteroids in the solar system, all the planetary bodies, then you're talking about, well, that's not something you do on a laptop unless you're just doing planetary motion of just the main planets. You could probably get away with that, but n-body simulation for everything in the solar system, then you have to have like GPUs and you get something a little bit bigger, which we have. We've got 2 of them, so the Tesla V100s. So so fun stuff. Yeah. It's really cool, but you can, like this type of stuff. It was hard to do in the past.
Right.
Yeah. Because if you wanted to build a model,
I was just gonna say, just because of the computing power.
Some of it is time, right? Just the time to do it. Like, so for example, like,
Such a simple setup.
yeah, so if you want to say do a image classifier for face, like you would have to go and say, take a picture, 10 pictures per person, okay, another picture of a face, you'd have to run, and it's just collecting the data, right? It's just like, oh my gosh, and then go through everyone here, and then you get 1,000 images, and then you go, okay, now I have a face classifier. Now everyone stand up, let's make 10,000 images, you got to take the pictures, right? And then you, and it's just getting the data to make the classifiers is the time-consuming part. Yeah.
Part of that thing, it automatically recognizes where the eyes are, where the ears
Yeah,
are.
yeah.
I mean, that's based on thousands of pictures.
That they have, yeah. So there is a data set behind the data set for this yeah, exactly. Yeah, there's another one. And they call them known anchor points. So eyes are a great known anchor point, yeah.
Snapchat's a good part of that, like doing those filters on your
Oh,
face.
yeah. That's
Crazy
right.
how
That's,
well this stuff
yeah,
works.
augmented reality.
I've recently, during this production run, actually, I had to.
All right. See if you can hear me here, hopefully. Maybe, no? Okay. I think this one might have died. Yeah. Okay. Can you hear me now? Okay, maybe it's working. All right. It was red and green flashing. All right, so we'll do one more thing before lunch, just kind of get you guys started with it, and then if you have any issues, we'll kind of work through that when you come, as you kind of trickle back after lunch. The one software that we can use, so there's so many block programming programs out there, so many platforms. This one works with Gadget. It doesn't have all the functionality, but for middle school students, they can start with some basic programming steps. And then ultimately, we'll move into text-based programming, which has way more capabilities. But PictoBlocks is one that we found. And if you have a laptop, you can download it. There is an app, but I haven't figured out how to connect it to Gadget with the USB cable. I think you can get on-the-go cables and work through that, but this is really probably more of a desktop or laptop type of activity. So that's one thing we're going to talk about later on, is what type of technology are you guys using in your classrooms? So, are you using laptops, or are you using, iPads, that type of thing? So that way we can kind of maybe make some changes before camp happens. So, but PictoBlocks, if you go, let me just escape here. So I just typed it in to the web search, PictoBlocks. It's actually this one here, the STEMpedia. So they have a download. You don't necessarily have to sign up for an account. I think you can if you want to save code and stuff like that, but they do have a download. And this is the application here. So you would download it, install it if you have those privileges to do that on your computer. So this is something, start, if you want to do that, start it, and then if you have any issues, we can work through it. But as you're kind of finishing up, I think then we'll head to lunch. I don't know if we have any formal way of doing that, but I think we can go early. So. What was that? Oh, you're probably, if you have a newer laptop, you're probably going to be a 64-bit download. PictoBlocks does work with other applications. So like if you are doing Arduino boards with like a Bluetooth module, They have other applications as well that you can use that with, but
So, I think that's kind of the last thing we'll do for lunch. We'll pick back up with PictoBlocks here. So if you want to install it, if you have any problems installing it, stick around. We'll be here for a second. But as soon as you got it installed, you can head out the doors to the cafeteria. I think everyone has a pretty good idea of where that's at this point. It's going to do the same process of just signing in, and we'll pay for you again. So, yeah, you're free to head over. Be back at 12:30.
If you don't install it, you might network with somebody during lunch to find out if somebody else can install it.
machine group,